Alright guys, so exponents. Can somebody tell me, looking at that picture right here, which one is an exponent? Which number? 4 or 3? Done. 3. So that 3 is an exponent. What do you think? Ooh, my voice went. What do you think that 4 is called? If it's not an exponent, what do you think it's called? Not a number. Yes, ma'am. A base. Good job. That bottom number is your base. So what does that exponent do? It tells me how many times to multiply the base by, what do we think?
4.
By itself. Okay. The exponent tells you how many times to multiply the base by itself. So if you look right here at 4 to the 3rd power, that 4 is my base, and that exponent is telling me how many times to multiply that base by itself. So I have 4 3s. I'm multiplying 4 times 4 times 4. And when I actually do that, I get an answer of 64. Okay? Make sense? Same goes for when I have a variable. So in this case, I have the variable x. I have it raised to the 5th power, so that means I'm going to multiply that x 5 times. Okay. And because I don't know what that number stands for, or what number that variable stands for, I can't simplify it any further. That's all I can do. Okay. So what do you think if I have 6 to the 2nd power? How am I going to expand that, Valentina? Good. So 6 times 6.
36.
And then that gives me 36. Good job. All right, what about 1 to the 4th power? Matthew, right? Good. 1 times 1 times 1 times 1.
1.
Which gives me 1.
Yeah.
Okay. Any questions about that? All right, look over here for the special names. So special names for 2 and 3. So first I have b to the 2nd power. What else can I say, Addison? Squared. Good. I could say b squared. But that only goes for exponents that are 2. Okay. What do you think b to the 3 exponent's called? What's the first letter? C. Carson? Camden. What you got? Cubed. Good job. So that would be b cubed. All right. 3 to the 1st. What do you think that gives me? Just say it. 3. What about 7 to the 1st? 7. 50 to the 1st? 50. So can you come to a conclusion about anything to the 1st power? Is always going to equal the base. Okay. So any number raised to the 1st power is going to be that number, that base. Right? But what do you think if you have something to the 0 power? Harper Joe?
It'll be a 0.
Why do you think it'll be a 0?
Because you're not multiplying it by.
But are you multiplying it by 0? Do you multiply that base and that exponent?
So 3. No.
No. Do you ever multiply the 3 times the 0?
Yes, but it means like 3 times like nothing. So
3 times nothing, but is nothing necessarily 0? Because anything times 0 is 0, right? This is tricky. That's why I'm asking.
it's just a base. It's just 3.
It's not 0. What you thought, Addison?
It's 3 because you don't multiply it by anything, so it just stays 0.
No, not 3. If it was 3, it would be raised to the 1st power. Mari.
Is it still like 0 because every time you multiply by 0, it's 0?
Rex. It's 1. Why? That's just the rule. It's 1. If you think about it, that exponent is telling you how many times to multiply the base by itself. So you're multiplying the base by itself, meaning it would be like 3 times 3 times 3 or anything, right? But you're not multiplying it by anything because it's the 0. So it's always just 1. Got it? So all you need to know is anything, no matter what number it is, raised to the 0 power is always going to be 1. Okay. So 50 to the 0 power is going to be 1 as well. Anything raised to the 0 power is always 1. Okay. Questions on that first page? Okay, flip over. Alright, so we've got 3 forms. We've got exponential form, expanded form, and simplified form. So, just like it sounds, exponential, it has an exponent in it. That means you will always have a number raised to a power. You'll have an exponent. Okay? And then expanded form is 10 written out 3 times, multiplied by itself. Okay? So this means I have 10 times 10 times 10. Okay? And then what's simplified form? 1,000. The simplified form is simply just multiplying all of your numbers together. Okay. Questions on that? Somebody want to come do the second and third one for me? On the board? Nobody wants to write on the board? Camden, go do the second one. So do the expanded form and the simplified form for this one. On the board. Like write it. You don't want to write it? Okay, Jet, go. Who wants the third one? After Jet finishes. Kamari. Got it. Do the second one. The next one that we need to do.
I don't think that's right, though.
I can't see. Yeah, that's right. Yeah, good job. Alright. You know what the next one I asked him?
But I don't want to do 20. I don't want to do that.
Down here.
Can I do the one after?
Give me the next one. So 1 to the 6 means I'm multiplying that 1 6 times, and then simplified is 1. Good job, Corinne. You have to do it without your hand on it. Good job. So 20 squared, so that means 20 times 20. And then simplified is 400. So 6 cubed means I'm multiplying it 3 times. Okay. So then what? 6 times 6 times 6.
36.
So then 36 times 6. It's a big number. Not quite.
180 and then 100. 260.
What is it? 260.
I'm horrible.
So you're not, you're fine. Alright, who wants to do this next one? 13 to the 0. Madison, right? Nope, that line right there is telling me that there's no way to expand it because you don't know how you're multiplying 13 by nothing. There you go. Big whopping 1. Good job. Alright, so this next one, we're going from expanded form into exponential form. So what is my base here? If I'm writing in an exponential form, what is my base going to be? It's going to be 7. And then how many 7s do I have? 3. So it's 7 to the 3rd power. Or how else could I say that?
7 cubed.
times 7 cubed. There you go. So then what's 7 times 7 times 7?
543.
What?
540.
Not quite. 343. Questions on that? Can I erase what we got so far? Okay, so the next one, I'm doing the same. I'm going from expanded into exponential. So what's my base going to be? 4. And how many of those do I have? 5. So I have 4 to the 5th power. And then when I multiply all that out, does anybody have it? Okay, Tia. Not quite. Close. Not quite. Right. There we go. 1,024. So I'm going to show you a little trick how we can do this. So technically I could say 4 times 4 is 16, 16 times 4, and then that times 4, and so forth, right? Or you can group it together. So you can say 4 times 4 is 16, and same here, 4 times 4 is 16. So you can multiply these two together, but you can't forget about that 5th 4. So you could do 16 times 16, and then multiply that answer by 4. Or you can do just straight 4 times 4 times 4. All right, what about this last one? What is it in exponential form?
5 to the
4th power. Good. Which gives me what?
500.
625.
625. Any questions on writing an exponential, expanded, and simplified form? Alright, so got a little bit of vocab recap. So at the bottom of our page, that very first one, an example of expanded form would be what? A or B? Expanded. Expanded is going to be A. Good job. And then exponential form is going to be what? B. It's going to be that number with an exponent. Alright, the base is the number being what? Multiplied right, by itself. Good. Multiplied by itself. And the exponent tells you how many times to multiply the base by what? By itself. Good. Questions on that page? Alright, go ahead and flip over. We are going to skip that next chart because it's exactly like what we just did. So skip on down to think about this. Alright, so here I have -9 in parentheses squared. So when I have that -9 in parentheses, what do you think is my base? 9 or -9? It's going to be that whole thing inside those parentheses. It's going to be -9. Okay? So that means my base is -9, and I'm multiplying it by itself twice. So -9 times -9. We know that a negative times a negative gives me a what? A positive. So my answer is positive 81. Do you think those parentheses really matter? You think it changes anything? Yes. If you look down here at the next one, -9 squared without parentheses, my base in this case is not -9. It's simply just that positive 9. Okay? But you can't forget about the negative. You're just pulling that negative out to the front, and you're multiplying the base 2 times. So now you have 9 times 9, which is 81, but you can't forget about that negative that you pulled out front. So your final answer is -81. Does that make sense? So if it's inside the parentheses, you are using everything inside those parentheses as your base. But if you don't have parentheses, that negative is not tied to that 9. It's just out front. So your base is just that positive 9. Okay? So if we look at the next example, negative 1 to the 6th power, do I have parentheses?
Yes.
No, I have no parentheses. So what is my base? Just 1. So that means that I have negative out front. 1 times 1 times 1, 6 times. So what is my simplified answer?
1 negative.
Negative 1. Good job. Okay, now I have parentheses. So I've got negative 20 in parentheses squared. So what's my base now?
Negative 20.
Negative 20 is now my base. So that means I have negative 20 multiplied by itself 2 times. So what's a negative times a negative? A positive. So what's 20 times 20? 400. So simplified is positive 400. Right now I have negative 6 to the 3rd power, or negative 6 cubed. So my base again is what? Negative 6. So now since it's cubed, that means I'm multiplying it 3 times. So I have negative 6 times negative 6 times negative 6. Hey.
I need to pick up that homework.
Okay.
I'm sorry to interrupt you.
No.
But you're going to get afterwards. I don't know what time she's going to stop at on her way home. So I thought I'd join them and get it just so you know what time it is.
Alright, so if I have negative 6 times negative 6 times negative 6, do you think my answer is going to be positive or negative? Positive?
Yes.
Alright, so if we solve it, first we have to do the 2. So we got to do negative 6 times negative 6. Gives me positive 36. A negative times a negative gives me a positive. So now I have 36 times negative 6. So now I have a positive times a negative. So what does that give me? Valentina. Positive or negative? Negative. Because down here I had positive 36 times negative 6. So a positive times a negative gives me a negative. So it gives me a negative answer. Okay. So you got to break it into pieces. Questions on that? Alright, flip it over. Now we're moving on to square roots. So, a square root looks like this. This symbol right here is called a radical. And then normally we have a number underneath. So if I'm looking at this, and I'm asked to find the area of this. What is the area? 4, because I have 4 boxes, right? So if I'm looking at that box and I want to know the side length, what is the side length? 2. I've got 2 boxes going across, 2 boxes going down. So if I have the square root of 4, I want to know what that is. The square root represents the length of the side of a square. So what is the length of the square? 2. So the square root of 4 is 2. The square root represents the length of a square. So now if I want to figure out this blank, what raised to the 2nd power would give me 4? Right. 2. So if I have 2 squared, that gives me 4. So looking back and forth, the square root of 4 equals 2, and then 2 squared equals 4. What can you say about those two operations? Not the same. So what can you say about square roots and perfect squares? don't equal each other because they're not giving me the same answer. I have the square root of 4 equals 2, and then 2 squared equals 4. Are they opposites?
Yes.
Yeah, they're opposites, right? Because if I take the answer, if I take the square root of 4, which is 2, and I square that, what do I get? I get the number under the radical. So I get 4. So they're opposites from each other. So another word for opposite is inverse. So these are inverse operations because they undo each other. So everybody see that? So if you square the answer to your square root, you're going to end up with the number under the radical. Okay. Alright, so what about here? What's my area of that? Yeah, just yell it. 16. So what is my side length? 4. So what do you think the square root of 16 is?
4.
4. Remember the square root represents the length of a square. So the length of my square is 4. So the square root of 16 is 4. Okay. So then what squared equals 16? 4. Questions about that? Okay, so what about when I'm given the actual numbers and not the squares? What's the square root of 4? 2. If I take 2 and square it again, am I going to get 4?
Yeah.
Yeah, so that's how you check your answer, okay? Square root of 100. 10. Remember, you're looking for the number multiplied by itself. Because if it's squared, that means you're multiplying it by itself. So it's never going to be 2 times 5 or 3 times 6 or 2 times 3. It's always going to be 4 times 4, 2 times 2, 5 times 5. Okay? Square root of 36. 6. Square root of 49. 7. Square root of 25. 5. Square root of 64. Square root of 121. Square root of 81. 144. Square root of 16. What?
Yeah.
We just did it up here. 4. Square root of 1. 1. Square root of 9. Good. Questions on any of that? No questions? So I can post it on Google Classroom. I just record whatever. I have to record all of my classes. Yes, that is going to go into the